Welcome to the Mahatma Gandhi Institute of Technical Education and Research Center. In 2004, a national level institute MGTA has been started in the field of engineering and technology as per guidelines of All India Council for Technical Education AICTE New Delhi. MGTA is approved by AICTE New Delhi, Gujarat State and affiliated to Gujarat Technological University Ahmedabad, which is also known as GTU. Our goal is to be an institute of generative ideas so that we remain relevant to our society. The MGTA has always been an organization on move with continuous effort on improving its processes and to maintain its relevance to the Indian science scenario, with adding new programs in its programmatic portfolio. We strongly believe in overall development of students, so for that we provide them a different platform like state level tech fest, project fair, different sports activity, which helps students to teach teamwork and problem solving skills to get physical health benefits, boost self esteem, and reduce pressure and stress for prove their skills in distinct area. Welcome to the lecture of Basic Electronics. Myself, Professor Gaurang Patel, from Mahatma Gandhi Institute of Technical Education and Research Center, Navsari. So, students, today we are going to learn about the chapter number 1, that is diode theory and application. And in today's lecture session, we will mainly focus on this topic, that is the ideal diode. So, in previous section up till now, what we have seen, that is how the PN junction is made, how the diode is formed, what is the forward bias and what is the reverse bias of the diode. So today we are discussing about the ideal diode. So basically, when you want to define the ideal diode, you can say that an ideal diode is a diode that acts like a perfect conductor when voltage is applied forward bias and like a perfect insulator. So when it is forward bias, it's behave like a conductor, and it is reverse bias, it will be worked as a perfect insulator. And when voltage is applied reverse bias, you can say it is worked as an insulator. Okay, so when positive voltage is applied across the anode to cathode, the diode conducts forward current instantly. So you can explain it in this way. And certain another things we will also see, what are the ideal diode characteristics. So basically, when threshold voltage, what is the threshold voltage? That ideal diodes do not have a threshold voltage, but in case of practical diode, now if we see there is forward current, then ideal diodes include unlimited forward current when any forward voltage is applied across their terminals. And what is breakdown voltage in ideal diode? That ideal diodes do not have any breakdown voltage. Okay, so these all are the characteristics that also we are going to learn in this lecture. And if someone will ask that what is ideal diode and what is practical diode, then also you can differentiate with the explanation like that ideal diodes acts as perfect conductor and perfect insulator, where practical diodes cannot act as perfect conductor and perfect insulators. Similarly, you can make the another difference, that is ideal diode draws no current when reverse biased, where practical diode draws very low current when reverse biased. And one more thing you can say, that ideal diode has zero voltage drop across its junction when it will be forward bias. So all those characteristic and the difference with regarding to practical diode, we will see in the depth in this explanation. So we will begin the depth discussion of the ideal diode. Okay, student. So students, we are going to start with the topic, that is the ideal diode. In previous lectures, what we have studied, basic function of PN junction diode, how the PN junction diode is formed, what is the p-type material, what is the n-type material, what is the potential barrier, and what is forward bias and reverse bias in the diode. Okay, so now in this lecture we will see what is the ideal diode. Ideal diode, that means what? Ideal, किसी भी चीज को ideal किसे बोलते हैं कि भाई जो एग्जैक्टली हमें वो चाहिए, ऐसा फंक्शन, ऐसा वो वर्क करे. ओके, आइडियल दैट मीन्स द रेफरेंस. ठीक है, सो द आइडियल डायोड दैट मीन्स के ऐसा डायोड का परफॉर्मेंस होना चाहिए. ओके, सो दिस इज द फिगर दैट इज गिवन ओवर हियर फॉर द आइडियल डायोड, that we will understood what this figure wants to explain to us. Okay, so this is the ideal diode that is shown to you, student. So in figure, there is a detailed graph of the forward region of a diode that is given. Here you see the diode current ID versus diode voltage VD. Okay, so where is the ID and VD? So in this figure you can see, just I will make it little small so you can easily see that. So this is the your diode current that is given on y axis, and on axis that is a diode voltage is given. So diode voltage in that graph, it will be up to the 2 volt, and your diode current that is maximum, it is reaches to the 40 milliampere. So you can see over here, from point up to the point 4 voltage, there is a zero current is going to be flow. So up to the point 4 voltage, हम point 4 voltage और उससे ज़्यादा थोड़ा सा बढ़ाते हैं, तब तक आपका डायोड का कोई करंट फ्लो नहीं हो रहा है. ओके, ये आइडियल सिचुएशन की बात है, आइडियल कंडीशन की बात है. देन आफ्टर व्हेन यू इंक्रीजिंग द करंट, when you increasing the voltage, you can see over here at this line you can see there is a small amount of current is going to be flow in that particular condition. And this third point, this is the first when it is going to be start increasing slowly, then second, and then third point. This third point, that is approximately or nearly, it is about the point 7 voltage. Okay, so that point 7 voltage you can see over here, that is the point 7 voltage. So this point 7 voltage, up after that point 7 voltage, this current is increased sharply or increased rapidly. Okay, so in ideal case, the diode characteristic is just like that. When it is reaches up to the potential barrier voltage, that is for the silicon 0.7 voltage, that you will get the current increasing of current sharply in that graph. Okay, so what is the statement is given over here? So that what I explained to you, that is somewhere in the vicinity of 0.6 to 0.7 volt, the diode current increases, and when the diode voltage is greater than 0.8 volt, the diode current is significant and the graph is almost linear. तब आपका graph क्या होगा? That is the linear. Now depending on how a diode is doped and its physical size, it may differ from other diodes in its maximum forward current and power rating and other characteristics. So ये भी बहुत obvious चीज़ है students कि भाई जब भी कोई हम चीज़ मैन्युफैक्चर करते हैं, तो मैन्युफैक्चरर पे डिपेंड रहता है कि वो उसमें कैसी इम्प्योरिटीज ऐड कर रहा है, वो कौन सी इम्प्योरिटी उसमें ऐड कर रहा है, और वो कैसे फिर उसमें दूसरे उसका सरफेस फैक्टर या उस पर डिपेंड करता है कि भाई ये कितना उसका कैरेक्टरिस्टिक कैसा रहेगा. दैट इज ऑल्सो डिपेंड्स ऑन द मैन्युफैक्चरर. ओके, नाउ इफ वी नीड एन एग्जैक्ट सॉल्यूशन, वी हैव टू यूज द ग्राफ ऑफ द पर्टिकुलर diode. Although the exact current and voltage points will differ from one diode to the next, the graph of any diode is similar to this given figure. Okay, so all silicon diodes have a knee voltage of approximately 0.7 volt. So जो भी आपके सिलिकॉन वोल्टेजेस है, उसका जो हमने देखा कि भाई नी वोल्टेज कितना है, 0.7 वोल्टेज. एंड व्हाट इज द नी वोल्टेज? जितना हमको अब बैरियर पोटेंशियल को ब्रेक करने के लिए जो वोल्टेज चाहिए, दैट इज नॉन एज आवर नी वोल्टेज. ओके, नाउ further you can see these are the statements given for that. Most of the time we do not need an exact solution. This is why we can and should use approximation for diode. We will begin with the simplest approximation called an ideal diode. In the most basic terms, what does a diode do? It conducts well in the forward direction and poorly in the reverse direction. So student, what it is given कि भाई बेसिकली हम क्या इस पे इससे जान सकते हैं कि भाई फॉरवर्ड डायरेक्शन में वो इजीली करंट को फ्लो होने देता है, और रिवर्स डायरेक्शन में इट विल ब्लॉक द वोल्टेज, और पुअर इट विल कंडक्ट द वोल्टेज पुअरली इन रिवर्स डायरेक्शन. ओके, नाउ it is impossible to build such a device, but this is what manufacturer would produce if they could. Is there any device that acts like an ideal diode? Yes, an ordinary switch has zero resistance when closed and infinite resistance when open. Okay, तो भाई ऐसी, वैसे तो क्या है कि आइडियल सिचुएशन दैट इज नॉट पॉसिबल इन प्रैक्टिकल केस ड्यू टू सम ऑफ द इम्प्योरिटीज ऑलवेज स्टेज टू देयर। सो हम ऐसा नहीं कह सकते हैं कि भाई जो हमें चाहिए वही कैरेक्टरिस्टिक के साथ वैसे ही अपना डायोड बिहेव करेगा। ओके, सो इन, लेकिन हम अगर उसको कंपेयर करना चाहते हैं तो एक स्विच के साथ कंपेयर कर सकते हैं। ओके, सो स्विच में आप अगर देखेंगे, आपके घर पे जो स्विच है अगर उसको आप ऑफ कर देंगे तो उसमें से करंट फ्लो होना क्या हो जाएगा, सडनली इट विल बी अ जीरो। ओके, बट इन केस ऑफ डायोड इट इज नॉट लाइक दैट। यू कैन सी ओवर हियर, it will be small current is going to start to flow, it will be small current is going to start to flow with point approximate point 0.5 voltage, and then it will be at point 0.7 and 8 voltage। but इन आइडियल केस में क्या है कि भाई पर्टिकुलर इतने वोल्टेज से डायोड करंट फ्लो होना ही चाहिए, तो ऐसा नहीं होता, इट विल बी डिफर। ओके, so over here this figure you can see there is a diode voltage and diode current is given, so this is the sharp increasing of current is given over here। Okay, so an ideal diode acts like a switch that closes when forward bias and opens when reverse bias। कि भाई आइडियल डायोड जो हो वो कैसे एक्ट करेगा, हमने ऐसा एज्यूम किया कि भाई वो जब आपको वो स्विच को आप क्लोज करेंगे तब वो फॉरवर्ड बायस होगा। ये सिचुएशन में व्हेन द स्विच इज क्लोज देन इट विल बी बिहेव लाइक अ फॉरवर्ड बायस। ओके, डायोड करंट को फ्लो होने देगा। और व्हेन स्विच इज ओपन दैट विल बी बिहेव इन अ रिवर्स बायस। ओके, so that's how it's look like, it is a symbol of diode, you can see there is the ideal diode symbol, switch is open when reverse bias we consider, there is a switch is open, switch open कर दिया है तो reverse bias हो रहा है, और switch को close कर दिया है तो forward bias हो रहा है। forward bias that means it will allow to flow the current, and reverse bias that means it will not allow to flow the current। Okay, then we can also see here there is an example is given for that। Now use the ideal diode to calculate the load voltage and load current। So students यहाँ पे एक ये सर्किट दी हुई है जिसमें एक आइडियल डायोड दिया हुआ है, तो उसके साथ हमें क्या दिया है, दोनों यहाँ पे जो एंड्स है उसे ग्राउंड कर दिया गया है, और एक वोल्टेज सोर्स दिया हुआ है दैट इज द वोल्टेज सोर्स that is of 10 volt and one resistance is given RL that is 1 kilo ohm। Now if they need to calculate the load voltage and load current over here, so simply हम उसे कैसे सॉल्व करेंगे कि भाई यहाँ पे एक तो ओपन सर्किट दिया गया हुआ है। now here solution is given, since the diode is forward bias it is equivalent to a closed switch। okay, so switch close हो गई है, visualize the diode as a closed switch, then you can see that all of source voltage that means the voltage that is having the source, that is कितने हमारे पास कितने वोल्टेज है सोर्स में, 10 वोल्टेज। so all of the source voltage appears across the load resistor, ये जितने भी सोर्स वोल्टेज है वो लोड के अक्रॉस में अपियर्ड होंगे। so हमारा लोड वोल्टेज कितना हुआ, सिंपली यहाँ पे सोर्स वोल्टेज 10 है, सभी के सभी वोल्टेज यहाँ लोड वोल्टेज पे अपियर हो रहे हैं, तो हमारा लोड वोल्टेज हो गया VL इज इक्वल टू 10 वोल्ट। ओके स्टूडेंट, सो हमारा एक सोल्यूशन तो आ गया 10 वोल्टेज लोड वोल्टेज। अब आपको फाइंड क्या करना है, नाउ यू आर गोइंग टू फाइंड आउट द करंट। now this is also very simple, we know the ohms law, that is for the finding current we what equation we are going to use, that is I is equal to V by R। so यहाँ पे स्टूडेंट्स हमारा वोल्टेज तो हमें पता ही है, इट इज एम्पियर that is 10 volt and resistance is also given, that is 1 kilo ohm। so आप simply if you divide 10 volt divided by 1 kilo ohm, so what answer you will be get, you will get the 10 milliampere। so your load current is the 10 milliampere। so student अगर एक दो मार्क में अगर ये क्वेश्चन आपका जीटीयू में आता है तो you can easily solve, don't be confused, just apply your basic equations and you can solve the or you can find the given डेटा। ओके, यहाँ पे हमने लोड वोल्टेज और लोड करंट कितने इजीली फाइंड कर दिया, आपने देखा। ओके, सो नाउ that's how you can solve this such kind of circuit problems। okay, now next we will see। so students finally as in every lecture, after completion of every lecture I will try to give you a message that please remember turn off the light when it is not required। okay, so please save the energy, save the electricity. Thank you very much.